Now I'm gonna record also the session. Now, look at this. Now, guys, look at this. It is going to be we are going to solve two problems today, the real life applications. One of them, we are going to deal with that today before we just go to take the break. Then we take a break for 5 minutes. Then when we come back, we just deal with the second problem and we are done for today. Now, look at this problem. What this problem is telling you, the one which you see on the left side, on the right side, you see it's a kind of a castle. And you are standing at point A. You are standing at point A, which is where you are standing. And from there, you are measuring, I should say, this is the angle, this is called the angle of elevation. Did you have it before?
No, not in math. No.
Not in math. I'm going to explain what is that. I'm just going to write it here. Then I'm just going to talk about this. What do we mean by this? I mean that for the first, imagine that you are standing here. Now this is the castle. You're working as a surveyor. You are trying to find the height of the castle. And that's the reason we have the edge here, which means that this is the height of this castle that you are just going to find it. But you have two measurements. The first measurement is when you are standing at point A. When you are standing at point A, you take the angle, you see that, okay, this is, let's say, this horizontal line, this is the surface of the sea. And you see that from here that you are all the way to the top of this castle, you measure with the instruments that you have the angle of 16 degrees. We call that angle of elevation. This is the angle that you are measuring from a reference line. The reference line for us is the surface of the ocean or the sea, that you see that the horizontal line. All the way to, let's say, to the moving arm. You have seen that moving arm on the unit circle, the thing that moves around. This angle is going to be the angle of elevation. Now, you just get the first measurement as a surveyor with the instruments that you have, Elisa. Then you walk 40 meters towards the castle that you position yourself at point B. Yes.
Is this problem on content?
No, because I'm gonna post it also there. And also when you are there, when you just move 40 meters towards, I should say, the castle, you see that you are measuring another angle, which is another angle of elevation. Now this is 28 degrees. And now this one is safe defense. It means that you cannot move further. Then as a result, you stop by making two measurements. One, the angle of elevation is 16. You took 40 meters coming closer to the castle. Then you get another measurement, another angle of elevation for 28 degrees. Now, then you go back to the office. You try to use these two parameters, three parameters, to find the height of these castles. That's the thing which we want to do. And that's the thing which we are going to use the basic formula in trigonometry. Now, look at this. Let me just go to, then let me just work here. Let me go to the next page. If I wish if I had a ruler here. Okay, is it okay for you guys if you just take a mental picture of this slide, I'm just going to go to the zoom. And because over there it's much more convenient, it has a ruler and also different colors. Now, the same problem that we were trying to solve, I'm just going to do that, just using, I should say, just the lines. I'm going to redraw it. And you see that it's going to be the line of reference. And this one is going to be the height of the castle that we mentioned. Now, we took two measurements. One of them was from here, that you were at point A, and you got the angle of elevation of 16 degrees. And the other one was at this point, all the way to the top, the point B, and you got another angle of elevation. I'm going to call this point A. I'm going to call this point B. And of course, that's a normal triangle. That's 90 degrees here. And also, I'm just going to call this length, which we have H. And also, I'm going to call this angle of elevation 16 degrees. And the angle of elevation here, I'm going to call this, how much? 28 degrees. Thank you.
No, it's 48. Oh, no, never mind. I'm pretty sure the first angle was 18.
It was 16.
16. 16 and 28. Now, also, we mentioned that here we just walked for 40 meters towards the castle, and we just took another measurement. That's exactly the same problem that we dealt with. Now we just want to find the height of the castle. I'm just going to use two formulas for it and two different methods. Please make sure that you just write two different methods distinctly on your notes. The first one, which we are just going to do, when I look at this problem, I see that it reminds me, if I go to, let's say, for example, if I just I use this slide, I'm just going to use this one. Look at this. I have a triangle here based on the definitions that we talked about that on maybe 2 sessions ago and also on the previous year. You remember that if we have an angle, I called it alpha. This one is A, this one is B, and the length is C. We have learned so far two measurements of the basic trigonometric ratio that they use the opposite length of an angle. Look at this angle. If imagine this is going to be your eye, you are watching the length which is opposite to you. One of these two measures that we have learned, one of them is the sine of the alpha, which we said that it uses the opposite length of the alpha, which is B over C. Or sometimes we do not have C. We have just, for example, let's say, for example, A. And we also remember, based on the things that we did, we said that we defined cosine of alpha as adjacent, which is A over C. Then what we did, and it's very important for this part of the lecture, was that we defined tangent of the alpha. Yes.
To be clear, sine and cosine, those are all when you're talking about the measurements of the sides, right?
That's right. The length of that's right. Then we said that the tangent of the alpha, based on the things that we have learned, it's the ratio of the sine of alpha over cosine of the alpha. And because they have both the same denominator, they are gonna vanish, then you are left with the ratio of the opposite length over the adjacent length, which is B over A. And that's the thing which is very important for us for this problem. We say that, okay, if I have two, for example, because look at this here, at this example, what we are looking at, look at this, it's very similar to this. We have the angle of elevation facing, I should say, the castle, which is the height H. And now we have also 40 meters as one of the sides. Then I think then the best ratio that we can use that incorporates the angles, the opposite length, and the adjacent length is the definition of the tangent. Then as a result, I say, okay, if I look at the 16 degrees here, if I look at this angle of elevation here, which is 16 degrees, you see that the tangent of, let me write it here. The tangent of 16 degrees, how much is that? Anybody?
Tangent of 16 degrees is the sine of 16 degrees over the cosine
Or the opposite, which is h, over this length, which I call it what?
AB.
No, much bigger than that, because 16 is facing the other one. That's right. Let's call it AC. Now, also look at this one. Look at this angle. This angle is 28 degrees. How do you define the tangent of 28 degrees? The opposite length over the opposite edge. And what is that? We call that BC. Am I right? Now, everyone is okay so far with this? Now, from this identity that I got over here, that I have AC, you see that very easily you can find with some basic manipulation, you see that the AC, which is the total length from where you were originally standing all the way to the castle, is how much? Is going to be the h over, that's right, fantastic, tangent of 16 degrees. Then you see that AC is equal to h over tangent of 16 degrees. Things are going to get a little more clear. Now we involve the height of the castle that we were expected to find. We see that it shows up here as h over tangent of 16. Now at the same time, look at this, Daphne. And now we have the same thing here. We said that tangent of, let's say, 28 is h over BC. Then as a result, how much is the BC itself? This length, I mean, it becomes h. That's right. Thank you. It becomes, then as a result, BC becomes h over tangent of 28. Now, these two are very important. I'm just gonna highlight them here. And also AC. Now, look at this. So far, what we have done, we only use one basic trigonometric ratio, which is a tangent of an angle. Because we had two angles of elevation, 16 and 28, I used it twice for the tangent to find these lengths. And look at this. I'm just going to go to the next page because I'm just going to look at this. Now, the thing which I'm going to do, we said that we call this A. At one point here, we called that B. We had it C. Here was how much? 40 meters. I mean, I'm just looking at this length. Look at this. From A to B, it was 40 meters. From B to C was h over tangent 28. And at the same time, we got AC, which is here, as h over tangent of 16. Yes, please do so. And guys, look at this. And now, everything is just turned out to be a basic geometry. Look at this, Julia. We have the whole length is h over tangent of 16. From here is h over tangent of 28, and here is 40 meters. And the whole AC is the addition of these two lengths. What does it mean? It means what? It means that I can write it like that. Obviously, we have AC is the sum of AB plus BC. Am I right? Now let's substitute the values in there. How much is the AC? That's right, h over tangent of 16. How much is AB? 40. How much is BC? That's right, h over tangent 28. And now things are turning to be a basic one variable equation. The only thing that we do not know in this equation, what is that? H. During the test, you have the calculator to find tangent of 16 and tangent of 28.
So that we can do.
That's right, we can do this. But look, still I'm not going to just put the values in there. I'm just going to express this equation just based on just the h. I'm going to express it based on the h, even without using the calculator. On the test, if you do this the same method and you do not find the numerical values, I'm just going to give you the full mark. Let's see what I'm going to do. I'm going to express h because I'm going to just isolate that. Then I take this one to the other side. It means that I'm just going to write it all the way from here. I have h over tangent of 16. I take h over tangent of 28 to the other side. Minus h over tangent of 28 equals to 40. Now, what I'm going to do at the next step, this is a little bit basic, I should say algebra. I'm going to factor h. I'm going to factor h. Then from the left one, I get 1 over tangent of 16 minus 1 over tangent of 28 equals how much? 40. Now, look at this. I have something inside. I'm just going to take the common denominator and just let's see what happens. Then what I'm left here with is this. I have h, which it was factored before. I have it there. What is the common denominator of these two terms? Tangent of 16 and tangent of 28. What is the common denominator? 8? How did you get that? Oh no, we just go, that's very sophisticated. We just go to the something basic. We said that tangent of 16 and tangent of 28, what is a common factor? You have no idea, it's so hard. Then let's mix everything together by multiplying them. We said that then as a result, the common denominator for us here is tangent of 16 multiplies to tangent of 28. You remember that before we just go for the second test? We covered that. Now, then what we do, we just multiply 1 to the one which is at the cross side of that, becomes 1 multiply tangent 28. I get tangent 28. And I have also 1 here, which multiplies to the one which it is observing, which is minus, because I have minus here, minus tangent 16 equals to how much? 40, thank you. And now look at this. Look at the h, which I'm looking for. I'm going to find the value for the h. Then it's as if I have one unknown, which is multiplied to a coefficient, which I know. Because you remember, tangent and 28 and tangent 16 are two numerical values. If you put it on the calculator, it gives you one number. Then what do you do? I divide both sides. Let me go to... Guys, please remember this one. I'm just going to go to the next page. Please read that for me. We had h. What we had here, tangent of 628 minus tangent 16, tangent 28.
No, it was the other way around. The bottom one was 16 times 1.
It doesn't matter because that's multiplication. The bottom one is multiplication, it doesn't matter. But thanks for noting it. Equals to 40. And now look at this. Everything here is known except for the value of the h. And in order to find the value of the h, I divide both sides by the coefficients of the h. Then what do I get? I get h equals to 40 over this, which is, let me write it with a different color, tangent 28.
How are you able to move the?
How can you just move the 40?
I didn't move it. I just still have it there. I'm going to explain it in a second. Look at this. Look at all the expressions which I have here. This creature here. It's all done as a coefficient. I divide both sides to this coefficient here.
Oh, okay.
And that's why I show it here. Everyone got it? Let me explain. Guys, look at this. Everyone. Everyone, look at this. Please do not talk. Look at this. The h which I'm looking for, that's the only thing which I do not have. But instead, tangent 28 and tangent 16, they are non-variables. Then I assume that the thing which comes inside the parentheses is known. Then I divide both sides by this coefficient to isolate h on the left side. That's what we do to solve the problem. Then when isolating the h, I divide both sides by this coefficient. It comes all the way in the denominator of the right side, and h is given. And that's the thing that you're looking for. Now, you say, what is the actual value of the height? You find it on your calculator, tangent of 28, tangent of 16, you solve it and divide 40 by it. Everyone has a calculator right now? Yes? It's a good practice. That's right, tangent 20. Let me just do this on the calculator. Because if you have a cell phone though, in your cell phone, search for online calculator. Yes. Of course, please.
You wrote 10. Why did you write 10 and 4 times at the bottom?
This is so interesting.
Oh, never mind, never mind.
What is 10?
Never mind, never mind, never mind.
But the rest of it, it's going to be something which you can do it on your own.
Yeah.
And
What are you talking about? The pretzel? No. Yeah, not a brain on this. Stop.
I got a,
How much did you get?
mine is not right.
It's going to be around 25 meters.
I got 432.
How do I get?
But no worries, that calculation with the calculators is just a kind of a fancy thing. The more important thing is that you get the idea.
I got 163.
Hold on. I got 24.75.
24, that's correct. Around the h is going to be around
24.75 meters.
24. 0.75 meters. Thank you.
Yeah, 24.75, right? I got four. I got wrong. I just did it. You can do it. Like, I did like your phone. Yeah. I was like 10 to 28. Then right now, I know the value. Then I figure what after you. Like,
Wait, you did do that? Wait.
Oh yeah. Okay.
Why do you divide by more than two?
Do I need it?
Oh, wait, I mean.
Yeah. So like divide, like figure that. That is, give the value. And figure it out. Then on your calculator, divide that. So divide 0.24 by 0. But it's not. But I'm not telling you, just put the formula. That was bottom one.
Yes.
What's your favorite thing to do?
No.
My favorite thing to do. There's a huge list. I have lots of. How about you?
Me? I don't know.
When I multiply that, I don't
Maybe
do
relax.
Me too. Having a cup of coffee, reading a book, watching a movie, and just relaxing.
And then like, I don't know how to do, yeah.
You're a prodigy, nice.
What did you get eventually? 24.75.
Okay, now.
What do you get? Yeah, well, let's play around it.
Okay, now guys. Now I'm just gonna solve a little bit more. The second method, which I'm gonna solve that, it's gonna be much easier. Very, very easier than solving an equation. The second method, the one which we did right now, it was the first method. Now, we are gonna do the second method. You have heard that, you just learned sine law last year, huh?
Yeah, cosine, sine, and.
Isn't that what we just did on the calculator?
Oh, no, it's gonna be different. I'm gonna explain it. Guys, I'm gonna go to the next slide. I'm just gonna explain and remind you of the thing that we did before. I'm gonna have.
When you put in your calculator like tangent, when you put in your calculator like tangent of 16, what is the calculation to get that? Like what is tangent? Like what is that?
The tangent?
Like when I put in my phone like tangent of 16, it gives me the value.
Oh, okay. What is that? It means that on the unit circle, you just, for example, look at that as a birthday cake. You start cutting the cake, but that small slice that it makes 16 degrees. Then on the unit angle, on the unit circle, you find the sine and you find the cosine and you get the ratio of those ones.
So then when we do the math, like when we're doing like sine of alpha, right? So let's say the angle we're doing on the thing is sine of 30. Can we not just put it in sine of 30 and get the same value, or would be different?
No, that's the same thing.
So then do we have to, can we always use the calculator for these tests? We're not always allowed.
No, just it's when you just want to get the exact value, use a calculator. But for,
Like for example, like the square root of 2 over 1, like that. And remember that?
Yes.
Those ones, would that we get the same answer if we did it on our phone? Like we're doing it.
exactly.
Mister, you studied neuroscience, right?
Mathematical neuroscience.
What's that?
You use math to describe the brain.
That's how me and him became friends. Like this summer, I told him I'm going to the university.
Be very careful, guys. Today class is not quiet and it's a little bit, I should say, exhausting. Guys, please quiet. Everyone's okay? Yeah. Nice. Now, Lex, it's quiet. Everyone quiet. Daphne and Simon. I'm just going to describe and remind you of the sine law, because with the second method, Daphne, I'm just going to use this very easy method The second method, which I'm going to use, it doesn't involve solving an equation. It just gives you the answer right away. But it requires we use the sine law, which you learned it last year. As a refresher, I'm just going to review that. I said that if we have a triangle, which we have A, B, and C, these ones represents each one angle of this triangle. A is an angle, and they are not normal. They can just have any acute angles here. And if you look at this, you notice that, for example, in front of any angle, there is a side. For example, in front of, for example, A as an angle,
It's Rania.
Rania. I don't know. Hi, Rania. D'accord. I can come right now. Is it good?
Yeah.
Yes, I'm just coming right now. Let me pause.
Bro, why are you drinking? So if you drink it, and then you said I don't want it.
Guys, I'm gonna go back to.
Yeah, now I lost it. Hey.
Guys, please quiet. Let me start this here.
I'm just interested.
What happened to? Oh, I lost it.
That's why she comes and interrupts the whole time.
Yeah, there's a problem.
No, that's the thing. It's the one time she doesn't. But we know who it is. I reckon.
Yeah, let's just say it out loud.
Guys, listen. Now I'm just gonna redo this stuff. Look at that. We had A, B, C. Guys, on this is the very last time. I'm asking you to be quiet. Otherwise, I just send some people upstairs. Honestly, for the first time that you learn to be quiet. Now, the angles B, A, and C. We said that these angles are acute angles, and each of them is facing one side of this triangle. One of them, for example, is facing this. We said that the length is C. C is small. And the length that the angle B is facing, I call it the small b. And for the angle which is A, I call this A small. What you have learned in the sine law last year, you said that any angle comes with the sine. We say that, for example, sine A. However, that angle, which has a trigonometric ratio as sine, is facing a side of that triangle. If this is capital A representing the angle, you remember it, the side is small, we say we build this ratio, sine A over A, and I do the same thing for the other angles. I say that, okay, it's gonna be sine B, which means that it's gonna be the sine of the angle B over the length B. And also the same thing, there is one more angle left, which is C. And we called it sine C. That's a trigonometric ratio because we learned that for any angle, we can define those ratios to build a new identity for them. Now, it comes also, it is facing the length C. What is the relationship between these ratios? From last year. Anybody remembers? We said that these ratios are all equal. Nobody remember that? Sorry, what? Oh, yes. You haven't learned it last year. Now, guys, look at this now then. If it's something new or that's for the first time that you see, look at this. For any triangle, it doesn't have to be necessarily a right triangle. We can define these ratios. We say that, for example, look at this. We have the angle A, we have the angle B, and we have the angle C. This is called the sine law. And what does it mean? It means that if you get also the length in front of each, for example, the angle A is facing this length, and I call this length A small, means, for example, between B and C, the length is A centimeter. And the length AC, which is faced by the angle B, it's called B small. For example, means the length AC can be, for example, 2 centimeters. And also the angle C is looking at the side, which is AB, which is measured by the C. Then we say this one. We say that we build this ratio. We say the sine of any angle divided by the length which it's facing, all these ratios should be equal. And that's called the sine law. Now, I'm going to use, yes.
This is not for a right triangle, right? It's
For any triangle, as long as you see a closed triangle, we can build up this law.
Also, the angles of the triangle doesn't matter. It can be-
No, no, it can be anything. Anything. 110, 20, and 50 degrees.
Okay, thank you so much.
Yes, no problem. Yes. Of course, please. No problem. Then now, as a result, I'm just going to use this law to go back to the original problem that we had. Then let's call this one sine law. We call this sine law. Now, okay, now I'm just going to go back to a new slide and rebuild the same problem that the castle that we were trying to find its height. We have this. We have this. We said that Simone and Daphne, anybody wants to go to Laura's office between you, or you feel okay?
No, I don't do.
Okay. Now, we had the same original problem. We had A, we had B, we had C, we had this angle as the angle of elevation as 16 degrees. We had this angle as 28 degrees. And we said that the length of the AB is how much?
40.
That's right. Fantastic. Thank you. 40, let's say, meter. Now, the problem that we were supposed to solve, and that was of our interest, was that to find this length, which I called it the height, and it just stands by the edge. Now, let's look, how can I use the sine law in order to find the edge? How many triangles we see in this diagram? 2. Yes, Ella, you have a question? That's right. Well, that's fantastic. That's right. Actually, I'm just fantastic. Great, Ella. Great. And now, as Ella said, I'm just going to use the sine law for these two triangles. Look at that. First of all, I have this angle 16, which is faced by what? By this length which I have. I'm going to call this one, let's say D. Now, if I look at this length, which is B to D, and I call this one A, why I'm calling this A? Because this is the length which is faced by the angle A here. Look at this. Then what can I do? Then I say sine of the angle A, which is faced by this length A, which I have no idea how much is that, equals to what? And what's the point? Look at this. What is our strategy? Our strategy is this. We said that, look at this. I have this triangle. Look at this, A, B, and D. Look at this triangle, A, B, and D. The question is that, I know this length 40, which I can put it here. Because all that we have at the denominator is what? Our length. Then now, the thing is that, what is going to be this angle? Because all the thing which I need to know is that if I call this angle, let's call that the angle as apple. I call that sine of apple over 40 equals this one. I know the A, which is 16 degrees, which it means that the sine of 16 degrees over A, which I do not know how much is this, and I keep it like that, equals to the sine of this angle, which I have noted here, over how much? 40. Then the thing which remains for me, and I just want to ask you that you think of it, how can I find this angle here? And that's what, yes. Sorry, say that again.
180 minus 28.
That's right. That's correct. I needed that idea. Thanks. Guys, look at this. I need this angle. But as Ella said, look at this triangle. I have AB all the way to the D. What is the total angle in this triangle? 180. How much is this? 16. What is the angle of this straight line? 180. How much is it taken? And how much is left for this? How much do you get for it?
You get 152.
152. Let me put this one here. It means that it's going to be 152 degrees. That's right. Thank you. And the angle that we have here for the apple, it becomes 100 minus 60 minus 152. How much do you get? 22? Right? How much did you get?
112.
112. No, I mean, 6. No, I mean for this angle, how much did you get in your calculator? 12.
Yeah. The apple is 12.
Apple is 12. Oh, thank you. Now, what do we have? I put sine of 12 degrees inside. Yes. What's red bar?
That's an apple.
Oh, this one, sine of the apple. I call this apple. I didn't have lunch yet. I felt hungry. I said, okay, let's call this apple. No problem. And the thing that we got, then guys, and everyone please listen, how much time do we have? Oh, today was so fast.
No break today, guys.
Now guys, look at this. What did we have here so far? The thing which we built was this. Nice. Look at this, sine 16 is given. You put this in your calculator. And please, next session, guys, please everyone, bring your calculator because we are going to practice with it. That when we just go for the test, when they say sine 16, we close our eyes and do it on the calculator. Please, everyone, next session, all bring your calculators. We know sine 16 is given. It's a number. Sine 12 also is given. It's a number. We have 40. We are left with 8. Then I can right away find the 8, which is going to be this length. In order to find the A, what do? I say, I'm going to flip all sides. I can write A as sine 16 equals 40 as sine 12. Now, the thing which is a little bit inconvenient is sine 16. I say if I multiply both sides by sine 16, I get A isolated becomes 40 over sine 12 multiplied by sine 16. I'm not gonna put the values in there. Yes.
Couldn't we do what we did before and just multiply sine 16 by sine 12 as a common denominator?
Because this is not addition or subtraction. They are two equal things. Then we just get it off. We just want to only isolate A.
Right.
If you multiply both sides by sine 16, you see that, okay, sine 16, they vanish. Then you have A equal to this. Then as a result, the value of the A for us here is how much? 53. That's right. How much did they get? 53.
Yep.
A becomes 53 meters. Fantastic. Now, guys, guys, look at this, everyone. We need only 2 minutes to finish the class. Look at this, guys. And now the second 53 meters. Guys, now look at this. Yes. Where have you been?
Hello.
Hello.
Where have you been?
Huh?
Where have you been?
Guys, please listen. Guys, please listen, everyone. That's the final part, and that's very important. Look at this now. The second triangle, we just started moving from the left to the right. We first deal with the first triangle. We find the value of the A based on the sine law. And moving forward, I find this triangle. That's the right triangle because I have a normal angle here. It's just 20 degrees here. I have this length 53. And I have what? I have 90 here, and I have the hypotenuse as 53. Am I right?
Yeah.
Now, guys, we need only 2 minutes, less than a minute to finish it. In this triangle, look at this. We are looking, Matthew, please listen. In this triangle, what we are looking for, we have an angle, we have a side next to it, and we have a right triangle. I thought that we have two ratios that define the right angles, that correlate, I should say, the left in front of an angle. One of them is sine, the other one is tangent. Well, look at this. Which one is going to be relevant for us? We have the hypotenuse and we have the angle. What is the definition of the sine 28?
Opposite over hypotenuse.
That's right, opposite over hypotenuse. We say that the sine of 28, what is the opposite of the sine 28? H that we are looking for. How much is the hypotenuse that we got? 53. That's right. Then what is going to be the H? That's right, 53 times sine of 28. And now, what we did, again, we find another method to find the value of the height. Can you do that on a calculator to see how much we get?
24.8 only.
24 point? Something similar to the first one.
Yeah.
That's right.
Yeah.
Then you see that. Now we got two methods to find the height of the castle by using the angle of the elevation and sine laws. Yes, Les.
Which one would be more accurate? Because they're both.
Both of them.
Oh.
Both of them should give you the exact same thing.
And what are those formulas called?
Sine formula.
Both of them are sine formulas?
No, this one, the first one is called sine
Sine law.
law. The other one we just used, I should say, the basic geometry.
Which one is the second one, I think?
The second one, which sine law, this one.
Yeah, and the first one?
Or just the basic geometry. There was no, that's right. No problem.
It's not. It's like this. I think it's very different. It's not like this. It's like this. Why? Don't ask. Okay, well, ask him about that. I didn't even.
See you everyone next session.